8th grade. Let's go over your note packet from yesterday. So remember, you can have this guy either printed out or digital. Either one works for me, just as long as they are completed. So we are calling it today's periodic table because looking back to your ed puzzle and also looking back to your reading from yesterday, the periodic table has changed several times throughout history, depending on new hypotheses and new evidence that has come up. But so today we're using the most current one. So the periodic table, we can our first two things that we want to learn about it are the advantages and how it is organized. So you should have found that people can identify many of the properties of an element by looking at its location or position on the periodic table. Where we see it on the periodic table can tell us what type of properties it has. Remember from our last unit, we talked about chemical properties and physical properties. That's what we're looking at here too. We can predict and know those chemical and physical properties from where they are on this table, okay? So, how about the organization? Well, if we look, the table is organized into columns, like so, and rows, and also blocks. There are blocks of each section in the periodic table. That's going to show us patterns of properties, okay? So how it is assembled on the periodic table, there's a method to the madness, okay? And we can find out different things about those. Now, how do we read the periodic table? Well, every element has a block like this, and everywhere that you see a whole number, that is going to be your atomic number. Now, refer back to I think it was a couple weeks ago when we were building those atoms. Your atomic number is the number of protons. That's telling you what element you are looking at, okay? So that's your atomic number. The S, it stands for sulfur. So each of your elements, it has an element name, which is this guy right here, but then it also has a symbol. I'm not going to require that you know all 130 symbols of those elements, but there are probably going to be about maybe 20 that I'm going to ask that you memorize. Those are the ones that are important and used the most, okay? So make sure you know those symbols for some of those common ones. So you have your atomic number, then you have your symbol, then you have your element name. Down here is your atomic mass. Remember, atomic mass is protons plus neutrons. And why it has those decimal points here is, remember, there's something called an average atomic mass. That's what's on our periodic table. That means it takes sulfur and all of the isotopes of sulfur, which remember is same protons, different neutrons. It averages those atomic masses together, so that's why it gives us that decimal point. So this is how you read this table. From this table, you should be able to find elements, find their atomic number, their name, their symbol, and their mass. All right? So, moving on, we have our little flow chart right here, which is telling us the periodic table of the elements. Groups are defined by columns. So, these are your groups right here. Each was group 1, group 2, 3, 4, 5. Columns go like this. What I told the in-class kids today is that think of G groups. I always think of G having a really long tail. That helps me remember that groups are columns. We also have periods. Those are the rows. So columns go like this, rows go like this. So these are your periods. These are your rows. That's how you find elements on the periodic table, by what by what group and what period. So just like we remember that G has that long tail, we're going to remember, I always draw my P like this. That helps me remember that periods are rows, so they're going down like this. Now, I made a mistake on your notes, so make sure that you know there's only 1 through 7 periods. I put 17. I don't know what I was thinking, because you have 18 groups, but only 7 periods. Now, in a group, so we're going back to our columns, elements in a group react with other elements in similar ways. So if they are grouped together, they're going to have the same chemical properties and the same reaction as those in their groups. On the rows, so on the periods, atomic number of each element increases by 1 as you go from left to right. So you know when you are going through your rows, through your periods on your periodic table, every time you go left to right, your atomic number is going to bump up by 1. So potassium has an atomic number of 19. Calcium has an atomic number of 20. So that is how you increase. So they increase this way, then over here 36, and then boom down 37. So that is just the generalization of how your periodic table is organized. Now, there are 3 groups that I want you to know starting out. So if you look here, this shows you how the whole periodic table is broken down. Not all of this was in your reading. I just wanted you guys to really be able to find your metals and your nonmetals on this one. We'll work the rest of this as the unit goes on. But what's most important for me now is for you to be able to find your metals, your nonmetals, and your metalloids. That's what we're going to work on first on finding. So on your periodic table, you'll see I'm on page 86 on your book right now. Your metals are anything that's in the blue. So do you see how they're all kind of grouped together except for hydrogen over here? All of your metals, they're all grouped together. You can find them in the same spot on the periodic table. Now, your nonmetals, these are going to be these yellow guys over here. These are what we classify as your nonmetals. Your metalloids, which they're sort of like the in-between, these guys are going to be your green. So you have your metals over here, your metalloids, and then your non-metals over here. Make sense? All right. So what about them? Why do we even bother separating them? Well, they all have different properties. So metals, you're going to find your metals on the left side and the middle of the table. Remember? We'll bring this back over here. So our left side and the middle, but except for hydrogen. These guys are all your metals. Think metals, guys, right? So science isn't tricky. It's what's around us. So your metals, they're going to be shiny, and they're going to conduct heat and electricity. So I'll zoom that in a little bit. You can't quite see it. So think metal, right? So they are shiny. Think like aluminum or steel. They are shiny, and they are going to conduct heat and electricity. So that means heat and electricity can travel through them. So think of anything that can like electrocute you, or a pan. If you grab a hot pan, it's hot because that heat transfers through it, okay? So those are our metals. Our nonmetals, these are all of these guys on the right side. Those are these guys right here, except for hydrogen. That's a nonmetal, but he's over on the other side of the table. Your nonmetals, they're going to often be gases. That's the state of matter that they're most likely found in. And they do not conduct heat or electricity. So heat and electricity those currents cannot travel through nonmetals. So nonmetalloids, their position on the periodic table is this little staircase that's between your metals and your nonmetals. In your book, it's green. Right here. These are these guys. Think of these as the halfway point between metals and nonmetals. So these have properties of both metals and nonmetals, okay? So all I want you to be able to do on this side, don't worry about filling the whole thing in, but you should have it filled in that these are your metals, and that these are your nonmetals, and these are your metalloids. That's what I would like you to know at the end of this packet. And also we know that horizontal rows are called periods, and the vertical columns are called groups. All right, guys, that was periodic table 101. There's nothing to hand in today. I just wanted to make sure that those notes are complete and good to go. If you have any questions, you can always email me. Other than that, have a fabulous weekend, and I'll see you guys on Monday.